This is a continuation of my overview of M202 movement planning. This video digs a little deeper into the calculations required to plan a ground convoy. More specifically, we'll go step by step through the instructor-led PE. Here are the key takeaways for M202 once again. During the first video, I introduced the basic formulas needed to plan a ground convoy movement. We'll explore these calculations in greater detail now. Afterwards, you should be better prepared to do the math required to build a movement table. On the left side of your screen, you can see a picture of the old movement calculator, which is still valid. You may find it to be even a little more versatile than the new movement calculator. Both tools are found on Blackboard and will work for the student-led practical exercise. You may or may not need to use all these tools during PE number 2. You will probably want to become familiar with them because these tools may come in handy during the remainder of AOC. This is an instructor-led practicum that will lead you through the process of planning movement calculations and building a movement table. In this scenario, we are planning a convoy for 3 battalions of Strykers. Let's suppose that we've been given a movement order that provides the information we need to begin planning. There are 5 basic things that we must calculate: average vehicle length, density, the time gaps, road space, and pass time. Our task is to take these outputs and complete the movement table. This slide depicts MSR-Red with its control measures and the minimum information from the movement order planners require to begin planning. Our rate of march is 30 kilometers per hour. There will be a 50-meter gap between vehicles. There is a 10-minute time gap between serials and a 5-minute time gap between march units. MSR-Red is 123 kilometers long. There are 3 legs to our route. Our convoy in this PE consists of a march column from 1st SBCT, 2nd ID, specifically the 3 infantry battalions with attached forward support companies. For the sake of simplicity, each battalion will comprise the brigade's 3 serials. We will organize each battalion into the same configuration for movement: Alpha Company, HHC, the FSC, Bravo Company, and Charlie Company. This is only an example. It is likely that the task force would not move quite like this. Commanders would consider the mission variables of METTC when deciding how to configure each convoy, as well as considering guidance from the movement order. Now that we've organized our march column into 3 serials and 15 march units, what happens next? Well, here's an example of calculating the average vehicle length for a Stryker company with sustainment assets from both the forward support company and the battalion medical platoon attached for movement. We'd also need to know the vehicle weight, height, and width, because this will tell us if the MSR infrastructure, for example, the bridges and tunnels, is sufficient to support our vehicles. To calculate average vehicle length, we need to find the total vehicle length and divide it by the total number of vehicles. In this case, our AVL works out to roughly 8 meters. Okay, so we need to compute the AVL on a spreadsheet or a sheet of paper. Neither of the movement calculators provided will do this for you. In this example, the AVLs for each company are calculated and multiplied by the number of vehicles. Once we've added all this up and divided by the total number of vehicles, we end up with an AVL of about 10 meters per vehicle. We need this figure to go to the next step and calculate vehicle density. We calculate vehicle density using 2 key inputs: the gap between individual vehicles and the average vehicle length. You can use either of the movement calculators to compute the vehicle density. The gap was provided in the movement order. We carry over the average vehicle length from our previous calculation, and the result is 16.67 vehicles per kilometer. Like I said earlier, you can use either of the movement calculators to compute the vehicle density. But let's take another look at this formula. These formulas provided in our doctrine assume that we can convert units if necessary. Remember that we are trying to find vehicles per kilometer. So how do we set this up? Let's look at this part of the equation. And now let's expand these measurements and add them together. So we get 60 meters per vehicle. How do we get vehicles per kilometer out of this? First, we take the reciprocal of this answer. Next, we apply a conversion factor and multiply. This will remove meters from our calculation. Our answer is now provided in vehicles per kilometer. As promised, here is the time gap formula found in ATP 4-16. We are looking for the aggregate time of the gaps in our convoy. You don't have to do this calculation by hand because the movement spreadsheets provided will do the math for you. But let's take a closer look at this formula. Why do we subtract 1 from March units? There are only 14 gaps between each March unit. We need this result to figure out road space later on. This slide shows how the number of vehicles, vehicle density, time gap, and rate of march are used to calculate road space for a March unit. We'll need this result to figure out the pass time for the convoy. Remember, the road space represents the distance between the lead vehicle and the trail vehicle in the convoy. One correction. We're calculating the road space for the march column, not a march unit, as I said before. Let's take another look at this formula. It can be all too easy to get some of these figures mixed up, especially when trying to keep units straight. Road space is a measure of distance. The output we want is in kilometers. Let's expand these formulas out. Don't forget that we must convert minutes to hours so that we can eliminate all units except for kilometers. So we can cross out vehicles, and we can cross out minutes and hours. And this side of the equation will yield 23.76 kilometers. And this side of the equation comes up with 40 kilometers. And the sum of these figures is 63.76 kilometers. And of course, we'll round up to 64. Too easy, right? We can now execute the pass time calculation because we've determined the road space and have been provided with the rate of march. We plug in the numbers, and the result is 128 minutes. This is the period of time between the lead and trail vehicle of the entire march column. But let's take another look at this formula. Once again, we have been provided with a constant, 60, without much explanation. Obviously, this has something to do with removing kilometers or hours. After all, we are looking for a time expressed in minutes. So let's expand the formula and multiply by our conversion factor. And we can strike out kilometers and hours, and this gives us an ugly fraction. But the resulting quotient is a bit neater. So let's review what we know. On this slide, we can use the DTR triangle to calculate the time required to transit the route. We know the rate of march. We've been provided the distance from the SP to checkpoint number 1. This works out to a 2 hour, 6 minute trip. and it takes a bit over 4 hours to travel the 123 kilometers from the SP to the RP. Now we can see how pass time and time gaps are combined to influence the total time an entire march unit requires to transit the route. So, if the lead vehicle crosses the SP at 0800, the trail vehicle will clear the RP 6 hours and 14 minutes later at 14 hours. Remember, the lead vehicle may hit the RP at 1206, but the trail vehicle takes 2 hours and 8 minutes to catch up. Okay, well, this is all well and good, but we build our movement table by serial, and each serial takes 36 minutes to clear a point. And the time gap stated in the movement order is 10 minutes. Wait a second, you say. How did I determine that each serial has a pass time of 36 minutes? Could this be as simple as dividing the convoy or march column pass time by our 3 serials? Nope. This doesn't work. Well, why? Well, we didn't take into account that the march column pass time includes 2 time gaps of 10 minutes each. So let's rewrite the equation properly and simplify. And here's the pass time for each individual serial. So, now we can fill in the table. This is fairly self-explanatory. Just remember that each serial has a 36-minute pass time, and we must account for the 10-minute time gaps after serial 1 and 2. So, for example, serial 1 clears the SP at 0836. 10 minutes later, serial number 2, its lead vehicle will hit the SP. And when the table is filled out, the march column clears the release point at 1414, as we determined earlier. Okay, at this point you should be ready to tackle PE number 2. If not, go back through this video as many times as necessary. Good luck!